So adding to yesterday's video, this is actually the same cup of water that I had from yesterday, but what I've been doing is for the last few minutes, I've had, instead of a pencil, I've got this penny attached, and it is attached, let me check this, to, oops, nothing right now. It was attached and will be attached to the positive end of my battery. See if we can get that in the light. So this yellow one right here is attached to the positive end, to the cathode from the battery, and that red wire here is attached to an anode. Let's see if I get the lighting right. Okay, so the red wire is attached to the anode. Electrons are flowing out of this anode, so there's going away from the battery in the red wire and flowing into the cathode, so it's going towards the battery in this yellow wire right here. So I take this piece of copper, and the electrons are going towards the battery, which means we're pulling electrons out of the copper here as we put it in, and I've got my red wire here attached to a spoon. Now, you'll notice different from yesterday that, see if I get some lighting better there, my heat's black and white, that we're getting bubbles still around the spoon, but you're not getting bubbles around the copper penny anymore. The spoon is bubbling all sorts. You'll also notice, since this is the same cup of water we had yesterday, that it's slightly bluer. Now, we've been worked enough that we know that copper compounds are blue. So what's happening is the yellow wire is pulling electrons toward the battery. It's pulling them out of the neutral copper and turning it into copper ions, copper 2+ ions most likely. In the meantime, over here by the spoon, it's spitting extra electrons in. Now it's still bubbling, okay, because part of the reaction that's happening still there is that the hydrogen is being reduced from hydrogen, essentially hydrogen ions, into hydrogen gas, so from H+ back down to 0. But the other thing that's happening is, as I turn this copper into copper ions, it's also being reduced. You know, there's copper ions swimming around in the solution, and if I let this sit here long enough, the copper will be oxidized over here on the yellow side, okay, where its electrons are flowing into the battery. They're flowing out of the copper. Okay, when we remove electrons from something, that oxidizes the copper to those copper 2 ions. Okay, and then over here, those copper 2 ions that are floating around in here are actually being reduced back down to copper. So if we've done this right, we should be able to see just a little bit that there's a copper coloring, okay, on my spoon, which I can't quite get. Now, if we were at school, I would actually have some copper sulfate, some copper compounds to work with, and they would look nicer, but we're doing our best here. So that's basically the idea of what can happen. It doesn't really matter what either of these metals are. What matters is what ion is in solution. It happens, the best way to do it is to, over here on our side attached to the positive end of the battery again, that's the cathode of the battery, but it's the anode for our reaction. We want it to be the same as the metal in the compound, in the solution, because that way when they get reduced over here on our cathode, then we're replenishing them. So I'm pulling them out, I'm plating them over here onto my spoon, but at the same time I'm replacing them into the solution over here on my penny. Okay, so there's a written version of this, but I thought I might try to see if we could get it to actually work. It's not great, but I can almost see. I know my lighting's not good today either, so almost see the copper color. Yeah, I don't know. Anyway, you can try it if you want. You have to leave the penny in for quite some time to actually get it to turn blue, but good luck.